Hey there. In this video, I'm going to walk you through the code I put together for my submission into the Flutter Hack Devpost challenge. Just in case you're not familiar with the project I put together, I called it Cross-Slide, and this is a quick demo of what the web version looks like. So the application is basically a combination of a crossword and a slide puzzle. So you'll be given a clue. In this case, the Earth revolves around it. And you have to figure out the word that you need to build, and you need to put it in the right either column or row. So in this case, we want to go one across. The word we want to spell is map. And so we would need to put, is sun. So it's got to be an S-U-N. So we have to move these around to get them in the right spots. And as you spell it, then the next puzzle will come up. It'll randomly mix this up. And the next one is the internet's favorite animal. That is cat. So you have to get the C in the space, and so on and so forth. You can continue to solve puzzles. There's a variety of things. So let's take a look at the code behind this project. Like any Flutter application, we're going to start with the pubspec YAML. Now you'll notice that in this package, there's really nothing, in this application, there's really nothing special in terms of dependencies or packages. In fact, the only one I added was URL launcher, and this is just to launch my website from the About page. So it's not required at all for the application. It's simply added for vanity purposes, I guess you would say. So then the next most important file, as you're kind of walking through a Flutter application, is going to be in the lib folder and your main.dart, right? So this is where your code is going to begin for all of your Flutter apps. And the way I like to lay out my apps, Flutter apps, are basically a little bit web-like in that I'm going to have routes that are going to send you to different screens, and basically I like to structure my folders to have models, screens. I do a theme, although the theme is usually very basic. And so where I put the views are basically in the screens. I often put my controller logic or business logic directly in the screens code, although you could swap that out into a controller's area if you wanted a true MVC sort of setup. And the models are generally where I'll do any sort of data storage or configuration settings, any sort of global variable definitions. So we'll dig through that in a minute. But basically, the main.dart, you'll notice that I include links into my two core screens. In this case, this app is really only two screens. It's the game and the About page. And so there's really only two endpoints, the game itself, which is the default home here, and the About page. So let's take a look at the About page first, just because it's the most basic. There's really nothing going on here. So it's a stateful widget, and basically, you see I did include that URL launcher here. It basically builds a simple scaffold with a back button and the ability, just the text along with a link to my website. So that just comes up when the little eye in the app is clicked on, and when you click on the little arrow to go back, it just pops it back on the navigation stack to the default page, which is going to be game.dart. Now, game.dart is going to be the file we're going to spend the most time sort of digging into, because it is the whole app. Excuse me. And again, in this one, we basically have we import our puzzles, and this is ultimately where you would add new puzzles. It's a simple data structure here for the word. The key is the word that you're trying to solve for. The clue is the clue that would be displayed inside of the app. And we have some stuff here around levels. That's for future, if you wanted to start to do some more involved stuff with the levels. And I have a more full-featured version of this app I am working on. It does take advantage of levels. It does do some word intersections and some more complex logic, but I'm still working on that from this code base. I started it from this code base. So Right now, levels is not being used in the game. So what does the game itself do? What is the code here? So let's take a look. For the most part, we're going to set up a bunch of variables at the top. And most of the stuff is commented in here, so I'm not going to spend a ton of time explaining everything. But I will quickly go through and show the different sort of logic things and sort of what we're doing with this app. So bear with me a moment. Each one of these functions is doing obviously slightly different things. I'm just collapsing them so we can make it a little shorter and easier to understand as we read through it. So really, with every stateful widget, you're going to build the GUI that you saw on the web app there. So the app bar basically is going to have the back button to go back to the screen, and then the about button. Actually, in this one there is no back button; it's just the about button. Normally, I do put a leading action that would be a back button as well, but I don't have it in this one. The body of the app itself is a list view. This is really just so that you can scroll out of the window frame. List views are really nice for having like things that are going to be long scrolling or maybe don't fit in the screen. Although for the most part this app will fit in the screen. Occasionally the instructions and or the clues, because if the box size gets too big, it may move you down. So I just kind of always put it in a list view. More often than not, I put stuff in a list view. As you can see, the slide puzzle section itself is really a container. Inside the container is a sized box, and the game size is a dynamically set value based on the number of boxes that we're going to have. And we're going to call a method called build boxes. That's actually going to put all the boxes in the right spots in the initial state. It's going to build all the animated widgets and put it all together. And then the clue section, again, is just another container. Really just a text output of the clue of the current puzzle that we're looking at. And then the section below that is the how to play and the game stats. And this is, again, really just some basic text widgets to sort of explain how to play, what level you're at, what stuff we're tracking. So you'll notice the main thing we really had to do from the beginning was this build boxes, right? So let's go back up and take a look at sort of the functions we've got. So we have build boxes. We have start timer, which is going to start a timer. We have shuffle boxes. We have check solution. We have change position. And we have build puzzle. And then, of course, we have our init state and dispose. So in init state, this is going to occur when you first load the view for the very first time. It's just going to build a puzzle. It's going to say we should start logging the time. It's going to start the timer. And when you close out a puzzle, it's going to basically just get rid of the timer for memory usage there. All the timer's doing is tracking how much time you've been playing for. In the demo, if you remember, there's a ticker sort of counting the time you played. We're tracking clicks. We're tracking the time you play, so you could do scores on that sort of stuff. So build puzzle is really the first thing that happens when you come in, even before loading the GUI. And what this basically does is resets our game control variables, gets a random word from that set of puzzles, sets the initial position of wherever the empty slot is going to be inside of our slide puzzle. It's going to decide randomly if it should go, if the solution should be in a row or a column. And then the real trick to this whole app is I have two two-dimensional arrays. One is a two-dimensional array of our animated positioned widgets, and the other is a two-dimensional array of our controls, which is what letter is in what spot at a given moment. And I'll explain sort of why that is two different arrays as we go through this. But so quickly in build puzzles, basically we have to, we hard-coded a level adjustment here, but in the future versions and the version I'm currently working on, again, I mentioned the levels in that puzzle control file over here, and those are basically, that's going to be used to instead of having this hard coded at every 5 up the level, it'll dynamically figure out the levels based on what puzzles are in there and what levels are available. So this at the moment is just using the modulus to say we've solved 5 up at a level, but that would be changed in a more production ready version. So we're going to take our words from our puzzles control, and we're going to make it available inside of this local function. That's basically what this is doing. We want to just take the keys. So the keys are just the things like sun, ant, map, dog, cat, right? We basically are building a list of words. So rather than a list, you're using an iterable. This is basically just a conversion thing with how keys works. And then at the same time, we're making an actual list of strings of the keys. And the reason we're going to do this is we want to basically go through that list of keys that we have in the game and remove the ones we've already solved. So in the demo I was showing you, we started with sun. It's going to randomly pick the next one to show. So obviously I want to randomly pick something that isn't sun because I've solved for sun already. So that's what this is basically doing, is going through and removing anything that was already solved, which we store in a list of strings as well. So assuming there is a puzzle left to play, we're going to go ahead and randomly pick one of the ones from what's left to play. We're going to assign the clue and the word now, because now we've picked one that we're going to use. And basically using the word length, we're going to determine the board size. So you notice in the examples here, we have 3-letter words, 4-letter words, and 5-letter words, right? And so the boxes get smaller. Well, the boxes stay the same size, but the game size gets bigger based on the situation of how many letters you have. And then that's going to directly affect how many rows and columns we have for a given grid. And basically, we're going to start off by always putting our empty slot in the last box. So if it's a 3x3 grid, we're going to put the empty slot, in the 9th spot there, the very last box. So that's why you see it's just simply the row count -1, the column count -1. It's also important to keep in mind in Dart, like in many languages, lists are 0 index. So that becomes important as you kind of work with two-dimensional arrays and arrays as a whole. So now we're going to randomly decide, should this be a cross or down, right? So it's one of two options. Just going to pick a random number, 1 or 2, actually 0 or 1. So if it's 0, it's going to be a cross. We're going to set the solve direction. We're going to pick one of the rows to say it needs to be solved for. So it should be 0, 1, or 2. Which to the user, we want to tell them 1, 2, or 3. So that's where you're going to see a couple little addition and subtraction things here. And so you either do that for a cross or down. And we've built our clue at the same time, because now we know if it's a cross or down. We can say what slot, what direction, what slot to solve in, and we know the clue, so we're providing the clue. So our variable is now storing that clue. And for the animated widgets that we're going to build, you basically have to define a top and a left x coordinate and y coordinate, right? And when you want to move something, you're going to move it you're going to update the left value or the top value. If you update the left value, it's either going to move left or right, depending on if you add or subtract to that value. And if you add or subtract to the top value, it's going to move it up or down. Since we're moving in a grid always, those are only the two you'll need, and it's the animated widget will actually take care of all those details for you. So now really what we have to do is go through our boxes and start to build our boxes and our letters. What are we going to put into each letter, into each grid? So we're going to loop through, for every row and column, we got to put something in a box that isn't an empty slot. So basically, we're going to check for our solve slot. This is the row or column. If we're doing rows, this is the row we want to put a word in. We're going to fill it with letters. So this word.runes for each basically will let you loop through every. This is a Dart thing that'll let you loop through every character of a string. I'm going to get the actual character that we are using because this is passing ASCII codes, I believe. And we're just going to keep track of what spot. Basically, we're going to have an ID. We're going to have a mapping of letters to IDs. So we know the top, the left, the letter, the ID, a background color, and a foreground color, because we're going to switch colors when boxes move into spots. And basically, we're going to keep one more array, dictionary, basically, that's going to say letter A is in what is associated to what ID. This is going to be used in our controls so that we can kind of figure out which letter is in which spot at a given moment. If letters are repeated, then we have to kind of use this to help understand like which specific version of A is in this spot, or where is this spot. As you play with it, it becomes more clear. I know it seems a little confusing as I'm saying it, so I apologize for that. We're basically just adding this the details of each letter to a list here, and then because we're working in a row, we're just going to add the size of the box plus padding to the left, so that the next letter will automatically start shifted over to the right amount. Otherwise, if it's not the row we're going to solve for, then basically we're in a row with we just have to fill it with random letters. And so it's very similar logic to what we just went through, but basically it's trying to assign random rows and letters. However, the last one is a special case where the letter is empty, because this is the empty slot. And so we're using an empty letter and an empty ID, and we're assigning it to empty so we can kind of understand where everything is at the same time. Right, so then the rest, like I said, very similar, but we're basically trying to find a random character, ideally that's not in the word, so we don't repeat a bunch of the same characters, although I don't do a huge check for that at this exact moment. And then we assign that letter to the spot, and in the end we're adding our boxes to our boxes array, which I said was one of our two-dimensional arrays we're tracking. We add each row, and we do this for every column that we need, so we should now have a full grid of values. And so now that we have our full grid of values, we can kind of go through and say, what is the actual ID that's in every starting spot? So what it's going to look like, basically, is you're going to have a list with... so a list inside of a list is going to be 0, 1, 2, right? And then it's going to be something like, again, 0, 1, 2, and again, 0, 1, 2. So this is what a two-dimensional array is going to look like in terms of, rows and columns. Now, for our IDs, what we're going to actually have is like 0, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to have something that basically is saying something like, 0 equals S, 1 equals U, and 2 equals N. And so on and so forth. But that's how you see, like, one across would be SUN or sun, right? And that's what our boxes array is going to look like this. And our controls array is, actually, this is going to be our controls array. It's going to have the IDs of the letters. The boxes are going to be actually a list of objects, two-dimensional array objects. And where it gets super confusing, as if this wasn't confusing enough, is that if you wanted the... let's say it's SUN, right? And the XY coordinates of this, because it's two-dimensional array referencing, S is in 0, 0. U is still in 0, 1. Now in XY coordinates, you'd think of it as 1, 0, right? So that's where it's a little confusing. And then N would be in 0, 2. So it takes a little bit of mental flip-flopping to kind of get around to all of that, but eventually, if you play with the code, you change some values, you'll see what's happening there, and hopefully it'll make sense. So after all of this, we've now basically got two-dimensional arrays built. One's got a set of objects that control our details about where the boxes should be positioned, and the other is a controls thing that is the IDs saying which ID is in what exact slot at a given moment. And then we're going to go to shuffle boxes. So shuffle boxes is basically just going to mimic a user clicking on the puzzle randomly to move the boxes around and sort of shuffle it up. Now there's lots of ways you could have approached this. I basically just did a loop of 50 clicks because we are setting the system up where the puzzle starts with everything in the solve slots. We obviously have to first start clicking and mixing it up. And by doing it this way, you basically ensure that the puzzle is always solvable because it starts in a solve state, and then clicking on it mixes those letters up. It's not the greatest shuffle because a lot of times it won't really shuffle the puzzle very much, and like you can solve it within a couple of clicks. But for demo purposes, it works. And so you could put, doing a production version of this, you'd want to kind of put a little more work into the shuffle boxes to make it have a little bit more logic and maybe get a little more complex for each level that you do. So at that point, your boxes are built, your controls are built, your boxes are now shuffled up, and so when the GUI tries to build the boxes, it's going to use those values. So we're going to mostly be making animated positioned widgets, and again, we're just going to create a list of these widgets, and you're going to see that the widget is heavily relying on this box's top objects that are in there to fill out the initial details in terms of the top and the left values, what letter to show, what's the color we're going to use, and what's the background color we're going to use. And then on tap, basically, when you tap on a given square, it's going to add to our click counter. It's going to call our changed positions, which we'll go through. And then every time positions are changed, we want to check our solution. And then obviously set state is going to re-render. So let's look at changed positions. And you'll notice in change position, what we're basically passing is just the ID of what we tapped on, right? So we know you tapped on ID 0 as an example. And so if we go to change position, we know the ID that we clicked on. We're going to go through that and figure out what is the current, through our controls value, two-dimensional array, and figure out what is the X and Y coordinate of what row and column did the person click on. And then basically we're going to ensure that they didn't click on the empty spot, because if they did, then nothing should move. If they clicked on something that isn't the empty spot, we need to determine if the empty spot is in the row or column that they clicked on, so that the appropriate boxes get shifted in the appropriate direction and the amount of space. And so that's basically what this code is going to walk you through. Like I said, I tried to heavily comment it so you can kind of go through this at your own pace and understand what it's trying to do. Maybe you'll find some bugs. There are a couple spots where a few of these things are maybe a little off. Again, for the demo purposes, I think everything works properly, but for production level stuff, I did change some of this up in my more recent version that I'm working on for a fuller app for this. So you can walk through it and kind of get a feel for what it is. At the end of the move, you're basically going to go through, find out what needs to happen in the controls. You're going to move the controls around so that now that ID 0 is now maybe was in slot 0, now it's in slot 1. What needed to shift around. Then you need to actually animate the boxes. So again, I said you just do that simply by updating the top and left values for any given box that needed to move. And the animated position widget itself, because you're changing those values when you do the set state, is going to cause that animation to occur from one location to the next, which is really the trick that makes it seem like it's a sliding puzzle. And then through all that, you have to check the solution. And so again, here, basically, you're going to loop through and see if in the solve slot that you were looking for, so either across or down, does it have all the letters that it's supposed to have in the right spots. And just to be a little fancier, we added this concept of the greens and yellows, which basically says, if it's in the right the right letter, but it's in the wrong spot, it should be a yellow. If it's actually the right letter in the right spot, it should be green. Everything else should kind of just stay white, and it'll come through and basically check, the across or the down based on what you were looking for, and then change those colors. And if it was, all the letters were in the correct spot, so for example, SUN was across the 1, then basically it's time to show the pop-up that you've solved it, and give them the option to go to the next puzzle, which is simply an on-click set, that we restart. We rebuild a whole new puzzle. We pause the timer until they click next so that the timer's not running while they're reading the fact that they solved the puzzle. And then you start the state and start again. And so for the most part, that's the whole system. The start timer, like I said, is really just a simple timer function. And it's only going to be adding to our counter if the timer is on or off. So the timer's always running, but our counter for time going up only occurs when we have the Boolean set to true. So that's, like I said, we can set it to false while we're showing a pop-up window, or if we wanted to give them a pause state or anything of that nature. So that's the whole set of code. I know it's a bit complex and confusing on the two-dimensional array stuff. If you look up the documentation for animated position widget, I think you'll kind of get a feel for what we're taking advantage of here, and then the rest of the system kind of comes down to those two-dimensional arrays and shifting things. Now, one question that you might have is, why is there two-dimensional arrays instead of one? The one that holds the animated position widgets, you didn't really want to shift both the location of the widget plus the spot within the array for the widget, because you'd be creating a whole nother set of boxes every time. So that's really why one simply changes the values of an animated position widget, and then the controls array actually tracks, now that you've changed the X and Y value of that widget, where in the row and column would it actually be. So that's my solution, at least. Hopefully it makes sense. Like I said, it's been fun to work with. It's an interesting little challenge. Hopefully it's a fun idea in a game. I am working on a mobile app based off of all this code that will have some more complex scenarios, situations, a lot more puzzles. So hopefully people like it and want to play it and want to check it out. If you have any questions, feel free to hit me up in the comments below, or hit me up on Twitter @Falicon. And good luck coding.